So how are the compression expansions of quadratic relations the same as compression expansion of functions? Well, we know that if we divide by the expansion factor, okay, so if I have x divided by a, f of a, we know that this is my expansion, okay? It works in the opposite. So it's exactly the same, okay? And we're going to see later on that if we have x minus p over a, yeah, that's my expansion. Okay, I divide to get an expansion. I minus to move to the right. I add to move to the left. Okay, so it works exactly the same. So the expansion factor is exactly the same as what we see in our function notation. Okay, so if I have, for example, y equals x squared, I know that y equals x over a squared. That's an expansion by a. Okay, so it works exactly the same. So how is it different? Well, the y's normally worked exactly the same. So when we had y equals x squared times, we'll call that b now, we know that times by b was expand by b. Okay, so now it's different because now when we see a b, it's divide by b means expand by b. Well, why is that the case? Okay, so y's were regular before, but now they're opposite. Okay, but that really isn't too big of a deal because really, why are they opposite? Well, it's because if we actually we see it now looking like this. This is what we see now. Okay, what's happening now is all the expansion and compression and shift factors with the y are now not with the x, but on the y side. So they're going to act exactly like the way they act with x's. So now it's actually consistent. Everything is backwards, not just the x's. X's and y's are backwards. So this is where we have to just make a slight adjustment and just say, well, now that our compression expansion factors are now not with the x for the vertical is now with the y, we treat it the same way we did with the x's before. So everything with y's are backwards, everything with x's are now going to be backwards.